There are four basic tasks that define a computer. They are input, storage, processing, and output. Every computer performs these four tasks, and any machine or device with these four functions is considered as a computer. Alright, good morning once again. Alright, so I welcome you back to class, and today we want to continue with our studies. And last time we started with the introduction to computers, and we've looked at certain important areas in learning how computers work. Today we want to continue and finish with the first lesson and move on. And after what we will learn today, we'll be taking our first class test. So get prepared. It has been long overdue. Alright, so today we'll be looking at how computers work. And we are going to look at the four basic tasks of a computer. And this will help you really understand how computers work. Now, before I begin, I'm going to play a short clip that will explain the four areas of how computers operate and let you understand what a computer really is. Then we will continue from there, and our subsequent lessons will take us deeper and deeper and build a strong foundation for understanding computers.
Everywhere you look, computers are changing the world. Whether they're on our desktops, in our homes, our pockets, or just about anywhere else. But while most of us use this revolutionary technology daily, we don't often ask, how do computers work? In this series, you're going to learn how computers really work, starting with what makes a computer a computer. Then you'll look at how information is represented inside the computer using tiny electrical signals going on and off at mind-boggling speeds. After that, you'll learn how computers use circuits to do everything from simple math to simulating entire virtual worlds. Next, you'll zoom out and look at the different parts of a computer that actually input, output, and store all that information. Finally, you'll take a look at what code actually is and how software controls hardware. So whether you're just curious about the devices you use every day, or you want to design the innovations of the future, the first step is learning how computers work.
My name is Mei Li Ku, and I'm a designer and an inventor. So some of the things I've designed have been at Apple, and now I design products for kids to use so that they can have an easier time in school. My other jobs include DJing and dancing. Computers are everywhere. They're in people's pockets, they're in people's cars, people have them on their wrists, they might be in your backpack right now. But what makes a computer a computer?
What does make a computer anyway?
And how does it even work?
Hi, I'm Nat. I was one of the original designers of the Xbox. I've been working with computers since I was maybe 7 years old, and now I work on virtual reality. As humans, we've always built tools to help us solve problems. Tools like a wheelbarrow, a hammer, or a printing press, or a tractor trailer. All of these inventions helped us with manual work. Over time, people began to wonder if a machine could be designed and built to help us with the thinking work we do, like solving equations or tracking the stars in the sky. Rather than moving or manipulating physical things like dirt and stone, these machines would need to be designed to manipulate information.
As the pioneers of computer science explored how to design a thinking machine, they realized that it had to perform 4 different tasks. It would need to take input, store information, process it, and then output the results. Now this might sound simple, but these 4 things are common to all computers. And that's what makes a computer a computer.
The earliest computers were made out of wood and metal, with mechanical levers and gears. By the 20th century, though, computers started using electrical components. These early computers were really large and really slow. A computer the size of a room might take hours just to do a basic math problem.
These machines are things of gleaming, vari-colored metal and numerous flashing lights.
Computers started out as basic calculators, which was already really awesome at the time, and they were only manipulating numbers back then. But now we can use them to talk to each other, we can use them to play games, control robots, and do any crazy thing that you could probably imagine.
Modern computers look nothing like those clunky old machines, but they still do these same 4 things.
First, we're going to talk about input. This is my favorite because what input is the stuff that the world does or that you do that makes the computer do stuff. You can tell a computer what to do with the keyboard, you can tell them what to do with the mouse, the microphone, the camera, and now if you're wearing a computer on your wrist, it might listen to your heartbeat, or in your car, it might be listening to what the car is doing, and a touch screen can actually sense your finger and it takes that as input on what it's doing.
All these different inputs give a computer information which is then stored in memory. A computer's processor takes information from memory, it manipulates it or changes it using an algorithm, which is just a series of commands, and then it sends the processed information back to be stored in memory again. This continues until the processed information is ready to be output. How a computer outputs information depends on what the computer is designed to do. A computer display can show text, photos, videos, or interactive games, even virtual reality. The output of a computer may even include signals to control a robot. And when computers connect over the internet, the output from one computer becomes the input to another, and vice versa.
The computers we use today look really different from the earliest thinking machines. And who knows what the computers of tomorrow will be like. My hope is that you get to help decide what you want the computers of tomorrow to look like. But across all computers, regardless of the different types of technology they use, they're always doing the same 4 things. They take in information, they store it as data, they process it, and then they output the results.
According to this video right here, you have seen what makes a computer a computer. You have seen how computers work. And it says that there are 4 basic tasks of a computer. I want someone to give me just one of them. Just one. Yes, Caesar. Input. Every computer takes in input. Every computer does what? Takes in input. Madam Loretta, give me one. Output. Computers also produces output. Mawena, give me one. Storage. Computers do storage. And one part, who can give me the last part? Those who have not spoken yet. Processing. So computers do 4 things. They take in input, they do storage, they do processing, and they do output. Now, every computer does these 4 things. And any machine that does these 4 things is a computer. If there is a computer that doesn't do these 4 things, then it is not qualified to be called a computer. Every computer does these 4 things. And any machine, regardless of how it looks, if it does these 4 things, it is also called a computer. When we get to the generations of computers, you understand the shapes of computers, how computers may look like. Not all computers look like what you are seeing on your desk. In the future, the kind of computers we are about to deal with, they are very different from what you see on your desk. With the 5th generation of computers, computers are even designed like human beings. They are designed like human beings. Computers are designed like cars. Computers are designed like several gadgets and in different forms. So we are going to see how computers look like. And in the olden days, we will see how computers were so large, how they filled an entire room. This will be treated in our subsequent lessons for you to understand. But today, we are talking about the 4 basic tasks of a computer. Now, we said input. Who can give me any input device? Who can give me any input device? Now listen to me. When you take all devices of computers, you will realize that either the device is an input device, an output device, a storage device, or it's a processor. Any computer device you take, it is either an input device, an output device, a storage device, or a processor. Who can give me an input device? Caesar. Pardon?
Light pen.
What did he say? Light what?
Pen.
Pen. Light pen. Okay. You mean the one we write on a digitizer to draw on the screen, eh? Okay. That's an input device. That's correct. Yes, madam. The keyboard is an input device. Why do you say the keyboard is an input device? Okay, so it takes information into the computer. So it's an input device. Everyone should give me something. We are talking about input devices. Mouse. Mouse is an input device. It sends input into the computer. So anything that sends input into the computer is an input device. Yes, that is fine. And we input with our audio, with our voice, and so the microphone is what takes that as input. That is correct. But why do you say it's also an output? How about your speakers? Your speaker, is it an input or output device? Why is it output? Speakers give out information. Okay. Speakers give out information. All right. Speakers give out information. So speakers are output devices. Now, if speakers are output and microphones are input, why is it then that when people want to speak to a large crowd, they will take a microphone? Who can explain that to me? We are saying microphone is input. If microphone is input, why is it that when you want to speak to a large crowd, then you go and take microphone? Okay. So Bright is saying that when you speak into the microphone, the speakers will amplify the audio and take it out. So it is not a microphone that is taking the sound to the people. It is what? The speakers. Okay, so anytime you are speaking in a crowd and you are given a microphone, it is because there's a speaker also at somewhere that will send the audio. Is that okay? All right. All right, let's talk about output devices. Who can give me any output devices? Speaker is an output. Yes, Bright, one by one. Any output device? Output, yes. Printer is output. Excellent. Yes, Mary. Headset is output. Okay. How about the headset that you can speak also into? For example, this one here, you can also speak into it. It's what? It's input output. All right, so that means some devices are called I/O device. I/O stands for input output. It means those devices are input devices at the same time output devices. So the headset that you can also speak into. Don't you see that when people receive phone calls, they can pick with their headsets? You can speak into your headset and also hear at the same time. So it's input and at the same time output. Yes, Mary, one output device. Projector is an excellent output device. Millicent. Monitor is an output device. Marina. Printer is an output device. All right, so let's continue with our lesson, how computers work. There are 4 basic tasks that define a computer. They are input, storage, processing, and output. Every computer performs these 4 tasks, and any machine or device with these 4 functions is considered as a computer. If you have studied computer architecture, you can see that this is how the architecture looks like. We have the input, we have the CPU here with its control units, the arithmetic logic unit, and the registers, and all come into the memory for storage, and we also have our output. This is how computer architecture looks like. So this is how computers work. This is what makes a computer a computer. Now, input. Input is a raw information or data entered into a computer by using input devices. Every computer needs input. Input devices collect information from the outside world, such as letters, numbers, images, and even sound, and convert them into computer language. This is some simple information here that explains how humans interact with computers. Please, are you here? For us humans to interact with this machine, we have to send our information in our human language to the machine. And the way we can send our information to the machine is through input devices. Input devices are designed to interact with humans. Input devices are designed to do what? Interact with humans, and they can be in any form, such as a keyboard, a touch screen, audio, anything that can relate with human beings. But one powerful thing about input devices is that whatever information they collect from humans, they will convert them into machine language. Are you with me? Did we talk about machine language? And we said machine language is what? Is binary. Now, every input device talks to computer in binary and is able to talk to humans in human form. However, it is designed. Some input devices are designed as heart rate machines that will take a pulse from you, or that you put on your wrists when you are exercising, and it will take your heartbeat and send it into the machine. So in any form that the input device can collect information, it takes it from humans and sends it inside the machine by converting it. So when you speak sound, once it gets into the machine, it is no longer the audio you are hearing from me. It is now binary code. When I speak and it enters the computer, it becomes code. So you may be asked to talk about the part of the computer system that relates with humans, and input is one of them. So input devices collect information from the outside world. It's able to take letters, numbers, images, sound, and everything and convert them into machine language. Input devices. An input device is any device. An input device is any hardware device that sends data or information into a computer, allowing you to interact with it and control it. So the only way we can talk to computers, instruct computers, tell computers what to do, take control over computers is through input. And there are several input devices. These are just a few. These input devices, they give humans control. So our keyboard is there, obviously. That is what we use to enter instructions into the computer. So it is called an input device. We have our mouse. When we click, it means we are sending information. We are sending input. When you use a touch screen and you tap, you are sending input. You are sending input. So you can either use a mouse to send an input or a touch to send an input. Microphone is an input. It takes your audio or your sound, converts it into binary for the computer. A scanner, have you used a scanner before? Most people have never used a scanner before. Who knows what a scanner is? Alright, so a scanner is a small device like this. This is a standalone scanner. And what it does is that if you have a photo or a document that you want to send into the computer, you will place the document inside it, you turn it. This one is upside down. You turn it in, close it, connect it to the computer, open the software and click on the button that says scan. And a light will pass over it inside like photocopy machine. When the light passes over it, it will take the image into the computer and the image will show in the computer. So in the olden days, before cameras, smartphone cameras became sophisticated and all that, all our hard copy photos, anytime we want to send them into the computer, we use scanners. You know, we used to have a lot of hard copy photos, and sometimes when we are designing posters, we have to take some of those photos and use for our posters. How do we get a photo into the computer? We don't shoot it with another camera into the computer. No, we put it in a scanner. The scanner will scan it and it will appear in the computer. If you have a letter, a document, any document at all, you use a scanner to do that. Then we also have what we call a digital camera. We all know what a digital camera is. And a standalone webcam. You know what a webcam is? Most people don't know what a webcam is. Just as most people have forgotten what scanners are. A few years ago, these were very popular gadgets or devices. But because today we don't use them much, and like these scanners, now they are attached to several printers. There are several printers that when you open the top, you see the top like a photocopy machine. Those printers are scanners and photocopiers. So today we don't have standalone scanners like this. We have scanners that come with printers. So they are all in one printers. Webcam. We used to use standalone webcams a lot. 15 years ago, everyone had one of these. Anytime you want to chat with anyone over the internet, this is what you use, the webcam. If you want to chat with someone, let's say you have a friend somewhere not close to you or even abroad anywhere, you need to place this beside your computer and open Yahoo Messenger or any messenger app. Today we use WhatsApp Messenger, Facebook Messenger, but at first we used to use Yahoo a lot. So you open to Yahoo Messenger and Yahoo Messenger will turn on. When you enable webcam, your webcam will come on. These things here are lights. They will throw some light on your face and your camera will capture you, and your friends too. Your friend's camera will also capture them, and you see your friend on your computer and they too will be seeing you, and you are chatting by typing, sending and receiving. So we use it for chatting and for video conferencing anytime you want to talk to someone. Today our webcams have been miniaturized or made smaller and placed in our laptop. So if you have a laptop and in your laptop you can see a webcam, you can see a camera in your laptop, then that camera is a webcam. It is called a webcam. At first, they were standalone, but today they are in laptops. So this is how they were before. You can place it on top of your monitor or beside your screen. You can use it this way, but or in any other way. But today, this is how we actually use them. Please, do you see this pointing here? Do you see this pointed camera here? Please, can you see this? Yes, you can see that in most laptops, right? That is the what we call webcam. All right, so that is a webcam. These ones are standalone webcams, but today they are mostly in laptops. So that is a webcam. All right, let's look at storage devices. Storage devices. Storage is a mechanism that enables a computer to retain data either temporarily or permanently on storage devices. A storage device refers to any hardware device used to store information permanently or temporarily. We'll be looking at why permanently and why temporarily. The device can be internal. Some storage devices are internal, some are removable or external to the computer. Storage devices are also known as storage media or storage medium. So when we talk about storage devices, please, are you with me? We have our famous hard drive, which is called hard disk drive or hard disk. Have you seen one of these before? Please, who has seen one of these before? Who has seen one of these before? We'll be doing computer hardware in this class, and we are going to learn all these devices. These are things you should know. Please, have you seen this before?
Yes, sir.
This is called a hard drive. A hard drive or a hard disk or a hard disk drive. You can call it by any of these three names and you are 100% correct. You can call it a hard disk drive, number one. You can call it a hard disk, number two. You can call it a hard drive, number three, and you are 100% correct in all three cases. Now, what do we use a hard drive for? This hard disk drive is what is inside your computer. We have a bigger form factor and a smaller form factor. When we say the bigger form factor, this is what we are talking about. This is a 3.5-inch form factor, and what it means is that this can only fit into a desktop system unit. We have a 2.5-inch form factor, which is smaller and thinner, and that fits into what we call laptops. It doesn't mean because this is smaller it is not good or it cannot store much. It doesn't mean because it is smaller it cannot store much. As a matter of fact, this can be more powerful than the big one. I'm not saying it is, it can be, because when you are checking the capacity, some hard drives may be just 80 gigabytes, some may be just 120 gigabytes, some may be just 250 gigabytes. This one too, some may be 500 gigabytes. So if this one is 500 gigabytes and this one is 120 gigabytes, then which one can store more? This can store more. It doesn't matter the size. I'm not saying that all of these are 500 gigabytes. Some are 120 gigabytes. Some are also 80 gigabytes. Some are also 250 or 260 gigabytes. Some are 1 terabyte. Listen to me, 1 terabyte. 1 terabyte. That same way we can have this one to 500 gigabyte, 1 terabyte. So if you want to know how much it can store, you need to check the capacity. And anytime you want to check capacity of any hard drive, there's a sticker on it. When you look at on the sticker, you will find the capacity of the hard drive. Please, are you with me? Hello? Every hard drive has capacity. When you take a hard drive, look for the capacity. Today, it is very rare to find an 80 gigabyte hard drive. That means an older one. Today, the minimum you should be expecting should be like 320 or 500 gigabytes or 1 terabyte. All right. Why do we call it hard disk? Listen to me. Why do we call it hard disk? We call it hard disk because there is an actual disk in it. We call it hard disk because there's an actual disk within it. Have you seen a compact disk before? When we say compact disk is the same as what? CD. Have you seen a CD before? Okay, listen to me. Have you seen a digital versatile disk before, or DVD? We call it digital versatile disk or digital video disk. DVD. Have you seen a DVD before? Okay, DVD is different from CD, and it's also different from BD. There's another one called BD or Blu-ray disc. That one you've not seen it before. Don't tell me you've seen it. Blu-ray disc. Now, the reason why we call this a hard disk, because there is an actual disk in this, and that disk is hard, not like CD that can break. I've broken CD several times. It's hard, made of metal. And so I took the time to crack open one hard drive just to show you. Please, have you seen inside of a hard drive? This is how a hard drive looks like. This one is a disk. That's why we call it hard disk. It's a metallic disk. Sometimes it is one, sometimes there are several of them stacked up and they all work together. Now, I opened this for you to see how computers store data. The data is stored on this. The data is actually written on this by this arm here. We call this arm the actuator arm. Actuator arm. Don't worry, in level 2 you'll learn more. And it has a head that does a reading and writing. It does what? It does what? Reading and writing. This is how a hard disk looks like. This is why we call it hard disk. If it doesn't look like this, it's not a hard disk. There are some storage devices that may be in this shape, but if it doesn't have this disk, it's not a hard disk. So this was a technology designed to help us store data in the system. And I'm going to explain how it stores data in the system. I also took the time to break open a laptop's hard drive. Please, have you seen it? Do you see the disk in it? This particular one, it is not just one. If you check, there are a number of them. At least there are 2 that I'm seeing. There are 2 of these disks. Now, when this computer, when this particular disk, when the computer is storing data, this is what happens. The data is located on the disk itself. It's actually written, physically written on the disk, physically. Now, the disk spins. Whenever the computer is on, the disk has to spin, and the arm needs to read like this. And so the data needs to run and get to where the arm is for the arm to be able to read. And so it runs and reads. It runs and reads. That is how it reads data and also writes data. So this is how it is designed. This is how it is designed. And this has been around for so many decades. And like I said, today we have bigger hard drives. We can store 1 terabyte, we can store 3 terabytes, 4 terabytes, just in one drive. This particular drive is inside your system unit and it's connected right here. This is too old. This is an older connection. You see several pins, and we see 4 here. This 4 is for power and this is for data. The rest are for data. The pin ones are for data. Every hard drive needs 2 main connections, one for power, one for data. One for what? And one for what? Today we don't use this old connection again. It's gone. It's actually gone out of the system. This type of connection is called PATA, parallel ATA, or parallel AT attachment. Parallel AT attachment. This type of connection. How do you know? Do you see plenty pins, several pins? The several pins is what you look for. And the Molex power connection here. These are 4-pin Molex power connection. This connector here is called a Molex connector. It was made by a company called Molex Corporation. So we call it Molex connector. So these 4-pin and the several pins, can you recognize them? That is the only thing you look for to know whether it is PATA or the modern one. This is the modern type. Just focus on this area. Does it look like the first one? Does it look like the first one? But you can see that there are 2 separate connectors there, right? There's a bigger one and a smaller one. Can you see? The bigger one here is for power. With the PATA, the 4-pin one was for power. The Molex was for power. And the long one was for what? Data. This type is called SATA, serial AT attachment. SATA, serial ATA, serial AT attachment. AT stands for advanced technology. Serial advanced technology attachment. Parallel advanced technology attachment. When it comes to drives reading data and writing data, they do it either with serial or parallel, or they do it in serial or parallel. So you'll be hearing a lot in computer hardware about serial and parallel. Are you with me? Today we use serial connections. Parallel connections work in parallel with many lines. So most parallel things are longer because they work in parallels. Serials work in series, one after the other. So most serial things are thinner because they work in series. So this small one you see here is for the data. So this is for data, and this big one is for what? Now, one of the questions they will ask you about the different types of hard drives is that, is it a PATA hard drive or a SATA hard drive? This one, is it PATA or SATA? This one, is it PATA or SATA? Sometimes they will ask you, is it SATA or IDE? Is it SATA or IDE? IDE. Integrated Digital Electronics. Is it SATA or IDE? IDE is the same as PATA. So if you don't hear PATA, you hear IDE. In Ghana here, you won't hear PATA most of the time. You hear IDE most of the time. But outside Ghana in US, you are going to hear PATA all the time. Hello? Hello? You want to learn computing? So this is a SATA hard drive. This is a SATA hard drive. And the capacity is what Loretta found. What did she find? 80 gigabytes. Okay, so most hard drives are in gigabytes, and they will range in gigabytes, and after gigabytes you start hearing terabytes. All right, so this is a little you need to know about hard drives. There are two types, PATA and SATA, and these hard drives are in the system unit. We have a 3.5-inch form factor and a 2.5-inch form factor. When you open your laptop, you are going to find this. Don't expect this in your laptop, please. This is in your laptop. Why do we need this? Because of storage. Why do we need it? Because of storage. Because of storage. Now, there are different kinds of storage. There are different kinds of storage. Hello? There are different kinds of storage. Now, the kind of storage that you need a hard drive for is for your own data storage. Let me just put it in those simple terms. Your data storage or your own storage. It is your internal storage device. And when I say your internal storage device, that means everything you own on the computer is stored here. And let me put in another way that will make it much clearer. Please, are you with me? Everything stored on, or everything stored in any computer is stored in the hard drive. Everything, A to Z. If you remove this hard drive from a computer, the computer will not remember a single thing. Let me put it in those terms. Any usable thing stored on any computer is here, and here. Any usable thing on a computer is stored right here. From A to Z. What possibly can be stored on a computer? Is it the operating system? The operating system is here. Please, hello. Is it the programs you have? Your Microsoft Word, your Photoshop, your Excel, your Access, they are all here. What is on the hard drive? Operating system is stored here. All programs installed are here. All programs installed are here. All of them. Number 3, all user data or user information. All your personal information, your pictures, your photos, your videos, your music, your documents, your everything right here. When someone opens a machine and removes this, the person has removed everything stored on that computer. Everything. Hello? Nevertheless, this is called secondary storage. This is not primary storage. Don't forget the difference. I said everything on your machine is here. From your operating system to your installed programs to your personal data to all your user files and whatever data, information, whatever, they are here. This is called a permanent storage device. Permanent storage device. I told you it's called secondary storage device, right? It's also the permanent storage device. That means whatever is stored here is always available unless deleted. That means we have other storage devices that are temporal, right? Hello. For example, this one. This is our primary storage device. Watch this here. Have you seen this before? Have you seen this before? This is our primary storage device. This is the main storage. When we could talk about memory, this is called main memory. Main memory. This is called secondary memory or secondary storage. Hello. This is main memory. This one. When we are talking about storage devices, this is the first one we talk about. This is memory, the main computer memory. But then this is temporal. What do we mean by temporal? We talk about what is stored on it. Then we talk about why it is temporal. First of all, what is stored on this? Let me tell you. When you on your computer, your operating system is stored here. Any program you have opened is stored here. Any work you are doing is stored here. And when I finish, you will tell me the difference. When you on your computer, listen to me. When you on your computer, your operating system is stored here. Any program you have opened is stored here. And any work you are doing is stored here. This is the main memory of the computer. This is what talks directly with the processor. And this is what does the storage. When the computer is in operation, I'll let you tell me the difference. What is stored here? Your operating system is stored here. All programs you have installed on your machine, they are all here. Everything you own on your computer, every file, every data, every information you own on your computer is stored here. What is the difference between what they store? Who can tell me? Tell me the difference. Let me repeat. Listen to me. When you own your computer, your operating system is stored here. Any program you have opened is stored here. Any work you are doing is stored here. As the computer is in use, this is where the CPU stores everything. When the computer is in use. What is stored here? Your operating system is stored here. All the programs you own on your computer that are installed on your computer, they are all here. And any file you ever own, any file, any data, any information is stored here. What is the difference between these two? They are not the same. If they were the same, we would not need one of them. Someone should tell me. Yes, Mary.
The difference is like when the computer is working, then all the work are being stored.
Exactly. Clap for Mary. I don't know if you heard what you said. Repeat.
So when the computer is in use, all that you are doing is being stored on the memory. But the hard disk is when like everything that is on the computer, whether in use or not, is being stored.
Excellent. Are you wearing all your clothes right now? Huh? Are you wearing all your clothes right now? Is it possible? It's not possible. You're only wearing one. Huh? But you have a place to keep all your clothes, right? Good. Now, everything you own is here. But what you are using right now is here. That's the difference. When you on your computer, this one, whether you've on your computer or not, your operating system is here. But when you on your computer, then the operating system comes here. I said when you open a program, I didn't say all your programs are here. I said when you open a program, so any program you have opened will come here. And whatever work you are doing will be here. But here, everything you own is stored here, whether you are using it or not. This is like your warehouse or your wardrobe. Or your database, or let me relate it to the storage part of your brain. Your brain has a thinking part and a storage part. Do you know that you know so many things? Do you know that you know so many things? But right now, are you remembering all of them as we speak? Okay, good. So when they ask you a question, then the information will be loaded from the hard drive into the RAM. So what is here is what you are currently doing, what you are aware of right now. But what is here is what everything you have. It's everything you have. We'll learn more about that later. Over here we have a USB flash drive. This is called a USB what? Okay, you may call it pen drive. It is not wrong. In US you never hear pen drive. You hear flash drive or USB flash drive. So USB flash drive is the same as your pen drive. Sometimes you also hear thumb drive. Thumb. Do you have a thumb? Do you have a thumb? It's also called a thumb drive. So we have a thumb drive, USB flash drive, or pen drive. Oh, I wish I had time to talk about SSD. Have you seen this? Okay. Your assignment is to go and find out the difference between a solid state drive and a hard disk drive. Write it down. Find the difference between a solid state drive and a hard disk drive. Next time we'll talk about them. The only thing I'll tell you about SSD drives right now is that they are the modern drives that have been designed to replace the hard disk drive. They are the modern drives designed to replace the hard disk drive. Did we talk about the work the hard drive does? Did we talk about the work the hard drive does? Good. SSD drive does the same things but better. But why would they work on a hard drive? Because hard drives have some problems. Hard drives have some limitations. They are good at storing large amounts of data, but they have some limitations. The reason why they have limitations is that technology is advancing so fast, so rapidly. The reason why they have limitations is because technology is advancing. And no matter what we do, we cannot go beyond the limitations of hard drives. And so we have to drop it and create something new. What is the limitation? Watch here. The limitation is this. The way it is designed. This is what has created the limit. Because for data to be read and written, the plate or platter or the disk needs to run as fast as it can for the actuator arm and the head to be able to read the information. What has happened is that computers have become 1,000 times faster than they used to be. And so even though these hard drives can run really fast, when we compare them to our memory, our RAM, the RAM is what I showed you before. Do you remember the RAM? When we compare them to the RAM and the CPU, hard drives are too slow. Hard drives are fast. Listen to me. But when you compare them to RAM, when you compare their speeds to RAM and the CPU, hard drives are too slow. Can you imagine how fast CPUs are? CPUs operate at 2 billion cycles in a second. Hello? The average CPU today runs at 2 billion cycles in a second. I didn't say 200 cycles in a second. I didn't say 2,000 cycles in 1 second. Do you know 1 second? Do you know 1 second? I didn't say 2 million cycles in 1 second. I didn't say 20 million cycles in 1 second. I didn't say 200 million cycles in 1 second. I said 2 billion cycles in 1 second. CPU runs at a speed unimaginable. That is why in just a blink of an eye, a lot can be done by computers. In just a blink of an eye, that is too slow for a computer. Computers can work so fast. Now, hard drives, because they have to physically spin, that spinning has not been able to catch up with the speed we need for the future. And so we have to come up with a different design altogether. A different design what? Altogether. Because the design is a limitation. So we have tried to improve and improve and improve, but the design is the problem, not anything else. The way it was created, it was designed, is the problem. So we have to drop the design and create a better design. So the better design is what we now call the solid state drive, SSD drive. And when you open into an SSD drive, you will not find any disk. This is a hard disk. Do you see HDD? What does HDD stand for? Do you see the plate? Do you see the arm? This is SSD, solid state drive. Do you see how it looks like? This is how it is designed. And because SSDs are designed this way, They are super fast. Super fast. Super fast. They are super fast. They are super fast. Solid state drives. So the design was the problem with hard drives. But with SSDs, we have modern design. And the way this one is designed, nothing has to spin for the data to be read. This one, data can be accessed at any location at any time. So this is very fast. And so modern machines are having SSDs. Hard drives are getting out of the system. They will still be around for some time because they have been there for so long and they have been improved in terms of their capacity. What they have not succeeded in is in terms of their speed. Remember the two words are used. They have been improved in terms of their what? Capacity. When I say capacity, what do I mean? Their storage volume, how much they can store. But what we have not been able to improve is their what? Is their what? Is their what? Speed. SSD is built for speed. SSD is fast. If you have an SSD machine, then you have a modern machine. The machine I'm using does not use hard drive. It uses what? SSD. That's the machine I'm using right now. But what SSDs have not yet been able to do much is capacity. So most SSDs are smaller. Most SSDs are smaller. If you get a 500 gigabyte SSD, then that's really big. My machine is 5112 SSD. That's super. 5112. Most SSDs will be 128, 256. If you get a 5112 or 500 SSD, that is serious. So because of more space, this will be around for some time before it finally gets out of the system when this completely takes over. And we have another type we call hybrid drives. Hybrid drives are designed with hard drives and SSD all in one case. Are you following me? Okay, so this is solid state drive. Solid state drive. Okay, we also have our floppy disk drive. Have you used a floppy disk before? Floppy disk drive. I'm not sure you've used floppy disk drive before, but this is exactly how it looks like. I have one right now, and this floppy disk drive, I don't think you have used it before, but 20 years ago everyone had a floppy disk drive. I said 20 years ago everyone had a floppy disk drive. We call them diskettes. This one, 20 years ago everyone had this. Everyone. The same way today everyone has pen drive. Do you all have pen drives? Do you have pen drives? Do you all have pen drives? Please, you all have pen drives. 20 years ago we didn't have pen drive. This was our pen drive. Everyone had this. So in our system unit there's a place we slot this, and this one can only store 1.44 megabytes. Finish. 1.44 megabytes, that's all. So if you have any document more than 1.44, forget it. Even one picture cry. Well, in those days things were much smaller. Today things are more quality and bigger, but those days things were much smaller. So everyone had this diskette, floppy disk drive. Today they are getting out of the system, but this is what we used to have as our pen drive. Then we also have remember we are talking about storage devices. We have CDs, DVDs, and Blu-ray discs, which is called BD. So this is a Blu-ray disc, this is a DVD, and this is a compact disc. Then we also have memory cards like the SD cards and the micro SD in your smartphone. They are for storage, and there are several storage devices. All right, let's look at processing. Processing is the action of calculating and manipulating information by the CPU. The CPU is also called a microprocessor. The CPU is also called what? The microprocessor, the processor, central processor, or main processor. And it is a brain of the computer. When we say it's a brain of the computer, we mean it is a thinking part or the calculation part. When the brain is doing calculations, this is what does the calculation. This is the processor in your machine. When we say the processor, we mean the computer. What does the computing, the computation, the calculation, the arithmetic, the logic, everything is this machine here. If there is one chip or one component in the entire computer, that is called the computer. This thing right here is the computer, and it is so small. It is so small that it will amaze you. But if you want to learn about technology, then welcome to the world of information technology. This is our computer right here. Everything else is there to help this computer. This is the computer. This is what does the computing, the main processing. Everything there is about processing. When we are inputting because we want processing. When we are storing, it means we are about to process or we are finished processing. When we are outputting, it means we are finished processing. Computer does processing, and this is a microprocessor, or is a processor that does the processing, and this is a computer. This is the most expensive part of a computer. If you want to assemble a computer, this is the most expensive part, because this is a computer. This is what determines how strong the computer is, how fast the computer is, what kind of computer you are having. This is it. When you are buying a computer, this is the first thing you check, nothing else. Nothing and absolutely nothing else. This is the first thing you check. Once this is established, then you check hard drive and memory. This is the computer. The computer. This, and it's a small chip you can put in the palm of your hand. When computers started in the first generations, this thing was the size of a football field. Have you been to a football park before? This thing was the size of a football field. And today, the one we are holding in our palm is 1,000 times more powerful than those days, the bigger ones that covered an entire football field. This is a central processing unit. This is a technology that has changed our world. This chip here is incredible. This is what we have been able to discover as humans. This chip. Its main function is to calculate every command that runs on the computer. It is one of the most important parts of the computer system. So we have, this is how it looks like I'm showing you. Have you seen what I'm showing you? Have you all seen it? Good. This is how it looks like. Sometimes the pins are on it, like what I'm holding. I can see the pins. Some of them are flat without the pins, but the pins are inside their socket on the board, the motherboard. So this is the back of some, and this is a Core i7 for desktop, and this is a Core i7 for laptop. A laptop CPU is slightly different from a desktop CPU. When you learn more, you understand the difference. Okay, let's look at output. Output is the processed data given by the computer after processing through output devices. Output devices convert information from computer language to a human readable language. So listen to me. When data is getting into the computer, it is in human form, and immediately it enters, it is converted into computer code. When it is coming out, it is computer code, but it has to come out in a human form. And so R2 devices are there to interpret machine code in human form, or in human readable, or in a human accessible language. So an output device is any hardware device that receives data from a computer, usually for display, projection, or physical reproduction. So a printer is able to take computer code and produce it on paper for humans to be able to read. A headset is able to take computer code and convert it to sound for you to hear as audio. A projector is able to display in pictures for you to see. A speaker is able to take binary code and convert it to sound for you to hear in your ears. Amazing. Monitor is able to display what you see. So these are display units. Then we have some called I/O. I/O stands for input output, and they are an input output device is any hardware device that is capable of sending data into a computer and at the same time receiving data from a computer. So it can send and receive. It's called an I/O, input output. Examples include touchscreen monitor. Why do we say touchscreen monitor is input and output? Excellent. You can input through the touch and you can also get your display through the screen, right? Excellent. Pen drive can be used to send data into the computer, can be used to retrieve data from a computer. When someone has something on a computer, can you take it out with a pen drive? So we can use it to take out data. That is why we call it an output and input at the same time, because we can send data into a machine from a pen drive. Okay, so a CD writer, we'll talk about all these things later. All-in-one printer. This printer here is a printer, is a scanner, is a photocopier, it's a fax machine. Then we also have fax machines here. Have you seen fax machines before? Who has seen a fax machine before? You see, as technology is advancing, some machines are getting out of the system. So at least today I've mentioned about 3 machines that you are not familiar with. Who can tell us a little about the fax machine? At first, every office had a fax machine. At first, every office had a fax machine. Today, most people don't have fax machines, and most students have no idea what fax machines are. Let's say, for example, there is a document. Who has any document? I have these 2 sheets of papers here, and these 2 contain an important business document that I need to send to a client. Let's say they are shipping orders and shipping information that a company needs to receive right now. How can I send this document to them right now? How can I send this document to them? Today you may think of different forms, but at first we had a fax machine. The fax machine is like telephone. It has a handset and it has a dialing pad. And it has a tray like a printer tray. You know what we do? We will put the document in the printer tray like this and take the handset like we want to make a call, and we will dial the fax number of the company. We will dial what? The fax number, just like telephone number. So at first, anytime a company is advertising, they will say telephone, fax. So when you dial the fax number, the fax machine in their office, they also have a fax machine. Someone will pick from the fax machine, and the fax machine will be ready to receive. Then what will happen is that the papers will go through the printer tray as if it's printing something, one by one. When the paper enters my machine, in their office, their fax machine will start printing. When it is going down here, it will go like this. In the office, it will become like it will be printing in the office. You can do this from here to Accra, from here to Nigeria, from here to US, UK, South Africa, anywhere. So by the time your document goes through your paper and it will come out and appear down here, a copy has appeared in their office, and they will just go into their fax machine and pick it up. They have the same document. Is it an interesting technology? They have the document too, the same document. It goes through your fax and appears in their fax. That is a fax machine. All right. So for the uses of a computer, you are supposed to read this by yourself. It's not my job to read this for you. So we are done with lesson 1. We'll be taking our test now, and God willing, next time we'll move on to another lesson. So uses of a computer. This is your job. You're supposed to read what computers can do, or what computers are used for. Advantages of using a computer. All right, so thank you for joining us in lesson 1. This lesson is titled Introduction to Computers, and we'll be moving on to lesson 2 in our next meeting, and we are going to learn more and get ourselves trained to become computer literates. So I want to thank you for joining us. I'll see you later. Bye.